Hello students, I am Dr. Tanmoy Vishwas. I welcome you all in my channel Chemistry, the Mystery of Molecules. I hope you all are fine. So today I shall discuss a multiple choice question and the question is in front of you. Reaction of this moiety first in the first step LDA in dry ether not, it is anhydrous ether, and second step benzaldehyde. What is the product? So the question is what is the structure of the major product rather than. So in order to find out the answer, 4 options are provided in front of you and one of them is correct answer. So you have to find out the correct answer. So as usual, I first request you, please pause the video and try by yourself and write your answer in the comment box, because self-evaluation is essential for self-improvement. Whatever, don't be confused whether it's right or wrong, but write it. Okay, so I believe you have tried by yourself. So now I shall explain the answer. Okay, fine. As usual, I first explain the nature of the reagent. Okay, so nature of the reagent, if you look at, see, this is LDA, lithium diisopropyl amide. Okay, it's a very strong base but very poor nucleophile. Why? Because presence of two bulky isopropyl group which doesn't allow this nitrogen anion to act as a nucleophile. That's why you may consider LDA as selective base. It's a very strong base as well as selective base. Fine. And in the second step benzaldehyde was used, which is nothing but can act as an electrophile. Fine. So that's a different issue. But main interest is this molecule. Okay, this molecule has many functional groups. For example, this part, this is actually a amide part, but in amide what can happen? Nucleophilic addition. But what we have used LDA, which is a very bulky, so nucleophilic addition is not possible. So another point left, that is the acid, means LDA can act as a base. So if LDA act as a base, which proton it will abstract? Two generally possible options. First of all, it can abstract this proton and it can undergo directed metallation or directed ortholithiation, and additionally it can abstract the proton from this. By the way, this proton is actually sp2 hybridized, whereas this is actually sp3 hybridized. Generally we observe that sp2 proton is more acidic than sp3 generally, because the more S character increases the acidity. But actually in this additionally, if this proton is abstracted, that could be chelated by this oxygen lone pair, like directed orthometallation. I have discussed this thing in a previous lecture, so you may visit if you want to learn more. So possible. Additionally, the lithium has some stability from this also, but still what will happen, that this proton will be abstracted. Question, why this proton will be abstracted? This is because surprisingly this CH3 is more acidic than the hydrogen. I shall explain after some time. Okay, so let's go to the mechanism for the process. So what happens in this case? First of all, as I told, that this proton is more acidic than this, so the LDA will abstract this proton and carbanion will be generated. This carbanion is resonance stabilized. I am not going in details. So what can happen in the next step? It can undergo nucleophilic attack on the benzaldehyde. By the way, one question may come in your mind that, sir, why this molecule, means exactly, let me draw the same thing here, NET2 CH2 minus, why this molecule cannot act as a nucleophile and this can attack here? It can attack open and it will leave. Why cannot happen this? Because the product, if you think, let's accept that possible, then what will be the product? This is the product. See, first of all, this is a 4-member ring. Second thing, that these and these all are sp2 hybridized. So sp2 means 120-degree angle, so extremely high ring strain. So reaction not possible. So carbanion will be stabilized in this way. and in the next step it will react with the benzaldehyde, because benzaldehyde is a very good electrophile. Okay, so this nucleophilic attack will happen. So after that, this. Now question, then how this happens? In such cases, I believe you need to draw the molecule little carefully. If you can do it, majority of problems. So let me draw here. So this is the CONET2, and this is CH2, this is carbon, this is the pH, and in this case this is the O minus. So what happens? This O minus can act as a nucleophile for this. So previously this didn't act as a nucleophile. Now why this? In order to understand that, you need to count the ring number. What do I mean by the ring number? See, this oxygen, consider 1, this is 2, this is 3, this is 4, this is 5 and 6. So if this oxygen attacks this carbonyl carbon, then it will result a 6-member ring formation. Let's draw this 6-member ring. So this is, and in this case here the carbonyl group will be there, and see, after this opening, what will happen? It will open, so O minus, so it will come back, and this NET2 will leave. So if this leaves, then it will result in this ring formation. So this side benzene along with this. So exactly, and I forgot to mention the phenyl. This is the phenyl. So this is. Now question is, why the benzylic thing will come, that why this proton selectively abstracted. Now the question, always remember one point, that the intramolecular reactions are always preferred. So intramolecular reactions are preferred over intermolecular. Okay, why? Because both thermodynamic and kinetic factor allows or encourage this story. Okay, so this thing we understood why intermolecular reaction happen. Now the question is, what is the reason for the abstraction of protons selectively? Means this sp3 proton abstraction selectively compared to the sp2 proton abstraction. Okay, so for that purpose we need to understand another interesting topic, that is acidity of benzene versus toluene. Generally what we expect, that benzene should be more acidic than toluene, but actually it is not, which is reflected by the pKa value. See, pKa value of this benzene proton is 43, whereas toluene 41. I know you will be confused. Why, sir? Why this unique or different type of observation observed here? See, in order to explain the acidity of any molecule, we need to understand the stabilization of the conjugate base. Okay, and if you look at the conjugate base, in case of benzene, the conjugate base, the carbanion, is the negative charge or the pair of electron is concentrated over a sp2 orbital, which is not in conjugation with the benzene nucleus. Whereas in case of toluene, after abstraction of proton, the pair of electron is in the p orbital, and it is undergo delocalization with the benzene nucleus. You can see these canonical forms are possible. So what means this complete delocalization of the negative charge possible, and we know that more electron delocalization is equivalent to more stabilization, and if the conjugate base is stabilized more, the acidity will be more. That's why toluene's proton deprotonation is preferred over benzene, and that is reflected in this reaction as a property. Okay, so in today's thing, what is the answer to this question? The answer is D. By the way, this is a simple chemistry based point to point explanation. Do we have any smart technique? I believe I have. If you don't know everything, based on your common sense you can have the answer. Okay, see, first stage we have used LDA in ether, actually we have to say dry ether, and second step benzaldehyde. Did I mention any workup or H3O plus like that? So we shouldn't have OH, we should have O minus. See, option number A, option number B, and option number C. In 3 cases I have mentioned this OH. So is it possible? So based on simple common sense you can eliminate these options. So what is left? This. So this is your answer. Based on common sense you can also do. That's why I believe common sense is a gift. If you have, you must be very much smart enough to utilize it in a proper place. Okay, so in conclusion, what you have learned today, LDA is a bulky base and that's why it can act as a selective proton, it can act for selective proton abstraction reagent, but it cannot act as a nucleophile. Okay, an interesting point is that benzene sp2ch proton is less acidic than toluene because the resonance stabilization of the produced carbanion. Okay, and intramolecular reactions are always preferred over intermolecular counterpart due to both thermodynamic and kinetic reason. Okay, kinetic reason. Fine. And the last part, what I told is a smart technique to get alcohol from an alkoxide, workup needed. Okay, otherwise you will never get alcohol. Fine. So this is the end of this discussion. I believe this video may be useful for you. I thank you for watching this lecture, and if you really like my teaching, please press the like button and write your opinion in the comment box such that I can improve my teaching in future. And most importantly, if you really like my lecture, then share it with your friends such that they can also enjoy the benefit. And most importantly, subscribe my channel Chemistry, the Mystery of Molecule, and please press the bell icon such that you will get the notification of every single video I upload. Okay, so I want to end this lecture in an optimistic comment that stay happy, stay blessed, try to maintain your mental happiness as well as physical health properly such that you can achieve your success efficiently. See you in my next video. Bye bye.